So in the previous part, we calculated that he has an acceleration upwards. He had an initial velocity downwards. So now we need to, part D asks, draw a free body diagram. And a free body diagram as he's slowing down. A free body diagram is one which shows the force vectors. So, what are the forces on this guy as he's slowing down? Well, we know he has a weight. There is a weight. This is equal to mg downwards, which I've just drawn. So his weight, this weight vector is equal to mg, and then I'll just say downwards. And this downwards would be interpreted as a negative symbol if I was ever going to do mathematics with it. But right now it's just a vector and it's pointing downwards. This is a magnitude, and there's my direction. There's a point of contact here with the ground, so I know that the ground is pushing. I know the ground must be pushing up on him, so there must be some kind of normal force upward. So this is upward. It's downward, downwards, upward, downward. Now, so if those are the only two forces I see on him. Of course, he's pushing down on the ground, but that's a force he puts on the ground. The ground pushes back up on him. Now, we've already, so let's consider what the net force is. The net force is simply the addition of all of the forces. So we have N upward minus the weight downward. And we know he has an acceleration. And any net force causes an acceleration by the very powerful formula F equals ma. That's Newton's second law of motion. It's causing acceleration. We know what his acceleration is. We know what his mass is. And this acceleration is a positive value upwards. So if I bring weight over on this side, I can see that N is equal to his weight. So again, N is balancing his weight, but it also causes him to accelerate upwards. So in this case, N, because he is accelerating upwards, N must be greater than his weight. He has a weight, a force downwards due to gravity, but this N has to overcome his weight, plus it has to accelerate him upwards or slow him downwards. So N is significantly greater than the weight. So if you have a weight vector of some length downwards, N is significantly larger than it. Actually, you can calculate what N is, depending on what this mass is. And this acceleration. You should be able to calculate some kind of numerical value for N, and then you can show in proportion. Let's say N was twice as big as the weight, then your vector should be twice as long as the weight vector.